Hello and welcome to Out2Lunch, a webinar series organized by the ESIP Education Committee and hosted by the Earth Science Information Partners, a national organization with over 120 members collaborating to advance the use of Earth science data across society. My name is Margaret Mooney and I have the honor of introducing Stephanie Schollaert, who is an oceanographer and communication coordinator at NASA Goddard. Thanks for presenting, Stephanie.
Thank you, Margaret, and thanks everybody for joining in. Today I'm going to show you two tools that can help you explore Earth science concepts using global satellite data. These are easy tools intended, let me just start sharing my screen. So these are easy tools intended for the science-curious public. Although scientists use them too, but the intended audience of these is people who want to go beyond the headline of a story, maybe to fact-check or put a scientific finding in context, but who don't necessarily have the software or time to write code to analyze observations themselves. So this first tool, ClimateBits, can give you background and context. ClimateBits are short 2-minute videos that explain essential climate concepts using global imagery. We currently have 10 ClimateBits videos covering a range of Earth science topics. You can see them here, and you can either watch the videos by clicking on the thumbnail on the left or on the title. You'll see the topics range from the top of the atmosphere, like ozone and solar radiation, down to the ocean. We have one on El Nino. And you can also click on the topic tab at the top to see to see them by category. So that's another way you can see them. So I'm going to just show you. Let's say you heard on the news that the policymakers are thinking about modifying Earth's albedo to counter global warming, and you start wondering, what's albedo? So here's a very simple explanation. I'll just show you the beginning of this to give you an idea of this tool.
The Earth receives energy from the sun, some of which is reflected back to space. Albedo is the fraction of this energy that is reflected. Albedo is critical for the Earth's energy balance and climate. For temperatures to stay in the same range from year to year, incoming solar energy must, on average, equal outgoing energy. Bright white clouds reflect the most sunlight and therefore have the biggest impact on Earth's albedo. These weekly maps are reflected solar radiation for the past 10 years. Lighter colors show more reflection and darker colors show less. Notice more reflected solar energy where there are persistent clouds, wind-blown dust from the Sahara Desert, smoke and pollution, and over snow and ice. One way humans impact the global energy balance is by modifying the Earth's albedo through industry and transportation, such as ship tracks and jet contrails. Agricultural burning and land use change also modify albedo. These land albedo maps show how reflective Earth's surfaces are from month to month. Bright areas with snow and ice have high albedos that can be close to 1, meaning almost all of the sun's energy is reflected back to space at these locations. Gray areas are missing data, either caused by persistent cloud cover or lack of sunlight. Notice that missing data peaks at the North Pole in December and at the South Pole in June. Deserts are brighter and more reflective in places with thick vegetation, such as rainforests. The albedo of the ocean is not shown here, but is just...
And that gives you a sense of what ClimateBits are. And so the next tool I want to talk to you about is called NASA Earth Observations, or NEO. And this is a collection of satellite imagery, NASA satellite imagery, and there's 50 data sets in here, and they're organized either by categories at the top. You can click on a category and see, for example, in this one we see the land albedo under energy as well as the reflected shortwave energy that was just in this video. You can click at the top, or you can also browse data sets by category down at the bottom here. So if we wanted to find the data sets of interest by the bottom, and you could click on, for example, albedo. Here we see January of 2017 shows up in the display window. And I should mention that if you want information about where these data are from and what they mean, what do the colors mean is described on the right-hand side, as well as the satellites and sensors that collect the data. And then below the main image, there's an About This data set where you can get a basic explanation, an intermediate explanation, or an advanced explanation for the very, very curious. So let's say we just heard about albedo in that video. So let's do a comparison of January 2017 in albedo versus reflected shortwave radiation. So I click, I'm going to first remove them because I just did this example. So now I have nothing in my imagery, and I can now add this one to the analysis. I'm going to go back and start all over. Okay, I'm going to add January of 2017 to my analysis, and then I'm going to go back and I'm going to get the reflected shortwave radiation, and I want to get the same month. So you'll see this one has either daily, 8-day, or monthly composites, and I want monthly. And I want to go back and find January of 2017. There it is. So I add that to the analysis here at the top, and then I click this Analyze button. And so then I've previously picked this area. You can pick whatever area you want. Let's say you want to do South America, or you want to go up to North America and see what impact the snow and ice in North America has. But today I'm going to look at Africa because we were just hearing about how deserts are very reflective compared to forests. So I pick the area that I like. I can either pick it using the cursor, or in select area you can put your coordinates there. And then you click Launch Analysis. I have albedo in this thumbnail and reflected radiation, and the yellow highlight indicates that that's the one showing up in the big panel below, the big display. If you want to click between them, you can either just click right on them to get reflected radiation compared to albedo, or you can do this step function. Now on the right, if you click on Data Probe, you can move around the image and see, and now notice over the ocean here, there's no albedo because it's a land albedo product. And then so you can just do some basic exploration and notice what values you have for both albedo and reflected radiation. I'm going to plot a transect. I'm going to go from this desert area in the north. I'm going to go down over this area that where the albedo is. So the albedo is high up in the desert area, and then it goes lower as it moves over the savanna, and it stays low. And if you want to move that plot around, you can move it to see it better. Now notice the reflected radiation goes down with albedo, but then it starts to go up again. And this is what you're seeing here in the map, which seems like clouds. So the rainforest has a lot of evapotranspiration that leads to cloud formation. And as you heard in the video, clouds are the biggest thing that cause solar radiation to reflect. And so I'm going to show you, if we outline a region, and I could do a funny shape, or I could do a square here, and then I could plot those data in a histogram. And you notice we have two different populations. So if I highlight the area here, all the parts of the plot within my magenta box show up here. So that's the desert. You see that really one-to-one correspondence between land albedo and the reflected radiation. Whereas over here, something else is causing, so reflected radiation down here is not due to the land albedo, it's due to the clouds that they have there. And then the other features that we have here are histograms, so you could do a histogram of the data in your region, or we could just select the whole area, the entire area, and do a histogram. And then you see the highest values, and if you want to move the plot around. Okay, so that's the general idea of this tool. I'll go back to the home page of NEO and show you. We've just added a blog here, NEO Analysis in 10 Easy Steps, in case you forget what I told you here and you want to take a look at remind yourself on how to find the data of interest and how to analyze it. And at the bottom of this blog, there's a form where you can provide feedback, and we really welcome your feedback. This is a new tool. It was just released recently, and we're very excited about it, but we want to make sure that we work the bugs out, and so your feedback is very welcome. Let us know how you're using it, what you find useful. We also plan to add some of these case studies in future blogs, and so again, if you send us your comments and your feedback, we can be sure to do case studies representing things of interest to you. So thank you very much. I'll take questions now.
Thank you, Stephanie. That was great. I see there's a few questions in the chat box. Can you address those?
Thank you, Margaret. Yes, let's see. So what is shortwave radiation, reflected shortwave radiation? And that is the amount of sunlight that's hitting Earth that's immediately reflected back to space. So part of the sunlight that comes to Earth is reflected immediately. Some of it goes down to the surface where it's absorbed, and then some of it's scattered back to the atmosphere. And this is Earth's energy budget. So generally we say the globally averaged albedo, Earth's albedo, is 0.3, meaning that 30% of incoming solar energy is immediately reflected back to space. It never enters the Earth system. And so if you change Earth's albedo, you could wind up changing that number and changing how much sunlight enters the Earth system. So let's see, the next question is about how is NEO different than Giovanni? And that's a great question. NEO and Giovanni are very similar, but Giovanni is intended, that's actually analyzing scientific data, and it's intended for scientists to use. And it has rigorous statistical tools within it, and it also includes models. NEO is just looking at satellite data sets, and it's just the images. So these images represent the data, but they're not climate quality data themselves. They take the imagery and they put them into NEO, and then the data values are approximate. So the data values go into the imagery, but then when you go from the imagery back to the data values, it's just an approximation. So it's not intended to be used for a scientific analysis like you would put in a peer-reviewed journal paper. You can use the images, though. The images are very beautiful, and a lot of people like to use NEO imagery in their papers, in their science papers. I was also recently on a cruise at sea where we had very limited bandwidth, and NEO was a great way to get a quick assessment of conditions. So we would plot the ship's track using this NEO analysis tool, and then we could see what we expected the chlorophyll concentrations to do along that track. It's historical. The data are approximately near real time, but for example, the chlorophyll data sets are a couple of weeks behind in updating. Some data sets update very quickly, and some have greater latency, and it all depends on the data set.
Well, I think it's amazing, Stephanie. Who's behind this tool anyways?
So this is Kevin Ward's tool, and then he recently had it redesigned to be web-based by Tom Whitaker there at Wisconsin. So yeah, it's a powerful tool, and now that it's web-based, it's lean and mean and ready for ready to be taken for a ride.
Well, I think it's great. I hope you get a lot of feedback on that about case studies. So thank you. Yeah, thank you everyone for tuning in, and we'll see you in 2 weeks for the next Out to Lunch. Thanks, Stephanie. Bye, everyone.